Okay, so today we are going to talk about the empirical formula and percent composition. So, the empirical formula what the empirical formula is it shows the proportions of atoms in a substance in the simplest form or simplest ratio. So it shows the proportions of atoms in a substance in its simplest form. Whereas if we compare this to a chemical formula, your your chemical formula is the shorthand way of writing a substance using chemical symbols and subscripts. So this is not the simplified version. Shorthand way of writing a substance using chemical symbols or using element symbols and subscripts. Okay, so for example, when we're talking about a chemical formula, we have CO2, H2O, etc. I know I did that backwards, so it's fine. So what we're talking about here is, for the chemical formula, I have 2 hydrogens and 1 oxygen. Alright, so let's move on to what the difference is between your chemical and empirical. So we're going to have our substance over here. We're going to have the chemical. Actually, let me move this down a little bit. We'll have the chemical right here, and then we'll have the empirical all the way over. So chemical formula, and then over here we're going to have the empirical formula. Okay, so we're going to have hydrogen peroxide. Underneath we're going to have glucose. And we'll have formaldehyde. Alright, hydrogen peroxide has a chemical formula of H2O2. Glucose is C6, H12O6, and formaldehyde is CH2O. Alright, so to find the simplest ratio, I'm going to just write them down here and I'll show you how to figure it out. So looking here, we have H2O2. These are both divisible by 2. That's going to give us an empirical of HO. Right here, 6 can go into all of these numbers. So that's going to be C H2O, because 6 goes into 12 twice. And then here, you have 1s right here. So since 1 is the smallest subscript, finding out what goes into all of these is going to be just 1. So you're going to have the same empirical as your molecular formula. So how do we solve for this? So let's say that I have H2O2, right? And I want to actually figure it out. So both of my subscripts, I have 2 and 2. I have to figure out which number goes into both of these and gets me the simplest ratio. Obviously, since these are both 2, 2 is going to go into both of them. So the way I always write this is like this. And then I just cross my numbers off, and I have HO. Same thing for C6, H12O6. I know that I have 6, and I have 12. 6 goes into both of these, so 6 goes in once here and twice here. So if I divide by 6, cross these off, and I cross that one off, I'm going to end up with, CH2O. And then last I have formaldehyde, and I have 1 and 2. 1's going to go into all of these numbers. 2 would not. It would give you halves, and it's got to be whole numbers for your empirical formula. So I have CH2O divided by 1, and that's going to give me CH2O. Alright, so that's the easy way of solving for the empirical formula if you're looking at a compound. But a lot of problems, you're either not going to have that, or you're going to have to determine other things first before you can solve that. And we'll talk about that later. Okay, so now we're going to talk about determining the percent composition. Alright, so determine percent comp is easy. One, we have to know what the chemical formula is. So we're going to write down the chemical formula. Normally, that's going to be written for you if you have problems to solve, but we need to know the chemical formula for this. Alright, for 2, we need to find the molar mass. If at any time I'm going too quick, just pause the video. I try to make these so they're not too long. Alright, and then number 3, we have to use the molar mass to determine the mass percent of each element. Alright, so let's do an example of this. So, what is the percent composition of H2SO3? So we have the chemical formula, so let's write it down. And we have to now determine the molar mass. I'm going to just round these. It's not really too important you're not going to get a vastly different answer. So we have 2 of these times its molar mass, which is 1 gram per mole, plus we have 32.07 plus 3 times 16. So that's 48 plus 2, that's 50. That's going to be 82.07 grams per mole. Alright, now that we have that, the reason I always do it like this is I have 2 grams per mole for hydrogen. I have 32.07 grams per mole for sulfur, and I have 48 grams per mole for oxygen. I already know what mass each of my elements has within this compound. So when I go to solve this, here's my total. So if you didn't know, hang on a second. If you didn't know, to find a percent, you just have x divided by n being your total, times 100%. So in this instance, this is n. And then to find the percent of each element, these are going to be your x values. So let's go ahead and do that. So we have H, S, and O. So we're going to have 2 divided by 82.30. Oops, not 3007. My bad. So 2 divided by 82.07 times 100%. Right here we're going to have 32.07 divided by 82.07 times 100%. And then for oxygen, we're going to have 48 divided by 82.07 times 100%. So let me open my calculator super quick. I'll move this over so you guys can copy while I'm setting this up. So let's do this. We have 2 divided by 82.07 times 100. So it's going to be about 2.44% or 2.4%. Let's go to the next one. We have 32.07 divided by 82.07 times 100. That's going to be about 39.1%. And you can either do one of two things here. You can calculate this, or you can just add these up and subtract them from 100. I'm going to go ahead and just do the calculation. So let's do it in parentheses this time so I don't have to do 2 steps. And that's going to be about 58.5%. So that would be how you're able to determine your percent composition within a compound. It's actually relatively easy. So if we add all these up, you're going to get 100. That's going to be 41.5 plus this, and that'll give you 100%. All right, so I have one more thing to cover. We're going to do 2 examples on if we're given percentages to actually calculate the empirical formula. It sounds a lot harder than it is, but it's really not. All right, so I'm going to go to the next page. All right, so let's go to how to determine determining the empirical formula. All right, so 1, you're going to need a percent composition or a mass. So you need a percent comp or mass. Usually that's going to be written into the problem. You're going to use that percent to determine the mass composition. You don't really need to do that. Use mass composition, determine composition in moles. All right, so you're going to have to either convert the percent or mass to moles. That's going to give you a molar ratio. And then you're going to use the composition in moles to determine the whole number ratio. Use comp in moles to determine the smallest whole number ratio. Okay, so we're going to go over 2 examples. I'm going to color code this just to make it easier for you guys to see what's going on. All right, so first let's write the example out. What is the empirical formula? This one's a little easy, but the next one's not as easy. What is the empirical formula? Let me rewrite that. Of a compound containing 36.5% sulfur and 63.5% iron. Okay, so this looks pretty complicated, but it's really not. So the reason I said you need the percent composition or moles, which we have a percent composition, we're going to pretend like, we're just going to assume since we have a percentage, because we have every percentage is out of 100%, we're going to assume that we have 100 grams. So instead of writing, it doesn't matter if you write it as percent or grams, but if you want to see why, if I have 100 grams of whatever, then that means that 1 gram equals 1%. That's the whole idea here. So knowing this, if my mass, I can just change this into grams. when I look, we have, to solve to get the moles, we have the percent of element or the mass of the element. Oops, let me do that in a different color. Divided by the molar mass of that element. So this is what happens. You have grams divided by grams per mole. So you're dividing by a fraction. So what happens is you have grams multiplied by moles over grams. Your grams get canceled and you have moles. That's where your moles come from in this calculation. So now, looking at this, let's write down what we have. We have 36.5 grams of sulfur, and we have 63.5 grams of iron. So looking at that, we have to find out what the molar masses of these are. I think I know these off my top of my head, but this one is 32.07 grams per mole, and this one is 55.85 grams per mole. It's something like that. Alright, so let's color code these. So that's going to be our mass, and this will be our molar mass. So now, we have to find out how many moles of each of these we have, because we're going to use that number to find our smallest whole number ratio. So we have 36.5, we have 63.5, and we're going to divide each of these by the molar mass. So 32.07, 55.85, and I'm definitely going to need a calculator for this. Give me 1 second. So 36.5 divided by 32.07, it's going to be about 1.14. Then we have 63.5 divided by 55.8, and that's also about 1.14. So write those in green. Alright, so normally you divide by the smallest one. Since these are both equal, if I divide by either of them, you're going to divide both by the smallest one. They're both 1.14, so it doesn't matter which one you pick. We're going to divide 1.14, and then these are both going to equal 1. So that means our empirical formula is equal to FeS, iron sulfide. Alright, so if you need a second to copy that, go ahead and pause the video. I have one more example to do. This one's a little more complicated. Not by much, but anyways, this is the last example for this video. Alright, so hang on a second, my phone keeps going off. Alright, so a compound is found to be 36.5% sodium, 25.3% sulfur, and 38.0% oxygen. What is its empirical formula? Alright, so this one I'm going to set up a little differently just so you can see a different way of doing this. So we have Na, S, and O. So I know that I have 36.5 grams of sodium, 25.3 grams. Oh, I guess I made this problem I copied didn't have 100% exactly, but we're just going to add a 0.2 there. It's fine. And then we have 38.2 grams of oxygen. So let's go ahead and we're going to find the molar masses of these. I'm going to write them underneath. So we know that sodium is 22.99 grams per mole. Sulfur is 32.07 grams per mole. And then oxygen is 16 grams per mole. So let's use our calculator. Clear all this off. So we have 36.5 divided by 22.99. That's going to be about 1.59, 1.6, something like that. 25.3 divided by 32.07. So this is telling us how many moles we have. It can be like 0.79, 0.8, something like that. 2 divided by 16. And this will be about, here, I'm going to just do one decimal place just to make this easier. So this is 1.6 moles, even though it should technically be 2, so I'll do 2. 1.59, this was 0.79, and this is 2 point, whatever that was, it was like 39. Alright, so, really it doesn't matter, you could just do one decimal place, probably make it easier for the division, looking at it. Alright, so we're going to take all three of these numbers, look for the smallest one, which happens to be sulfur, and we're going to divide all three of these numbers by the smallest one. So divide by 0.8, 0.8, 0.8. When you divide by the smallest one, that's telling you how many of each of these you have compared to this one. So it makes it really easy because it's compared to all of them, really. So this is going to be 1.6 divided by 0.8. If you move the decimal, it's very easy to see this is going to be 2. This is obviously 1. Let me fix that one because that is horrible. And this is obviously going to be 3. So looking at this is very easy. Our empirical formula is going to be Na2SO3. And that would be your final answer. Alright, so there's going to be another video after this where we're going to talk a little bit more about solving for empirical formula, but also how you can determine what the molecular formula is given a molar mass and an empirical formula. So I will see you all in the next video.